Yo, I'm Yorke. Welcome to Permissionless Interoperability and Warp Routes. I'm from a project called Hyperlane. We're a interoperability protocol focused on modular security and bringing interoperability to all chains. So we're very chain agnostic. We're hoping to kind of support whatever chain you guys want to be working on in this hackathon. You can stack some bounties. This is my colleague Nam. We're going to hopefully do a live demo for you guys at the end here. Fingers crossed. But yeah, first let's hop into what is permissionless interoperability and what are warp routes, and why should you care? So just as a definition to start with, interoperability in our eyes is composability amongst dApps that are on different infrastructure. So whether that's like a dApp that's on an L2 composing with a dApp that's on an L1, or a Cosmos app chain with a dApp on Ethereum, or something more exotic, that's what we define as interoperability. And if you look at the dApp ecosystem in the past couple of years, what you'll find is that the infrastructure that dApps are choosing to deploy on is kind of increasingly divergent as people start to realize the benefits of different trade-offs throughout the kind of layers of the blockchain stack. They're choosing like more and more diverse trade-offs. So, we have kind of the hot stuff right now is like data availability layers, like having this infrastructure layer that's optimized for this specific task. There's also a lot of people thinking about app chains and kind of the different economics that you can capture as a dApp developer by kind of controlling the entire blockchain stack. So these are just a few examples, but it should be abundantly clear by now that like this is only going to become increasingly diverse. So the Ethereum ecosystem's focused mostly on kind of the roll-up side of things. They've kind of committed the past couple of years to that scaling strategy, but it's by no means kind of like, I think, a final destination. They still want to work on these other things, plasma, sharding, etc. And we're seeing dApps adopt these new roll-up architectures in the Ethereum ecosystem. So Arbitrum Optimism, kind of the two canonical examples of like big roll-up ecosystems. There's a bunch of DeFi happening on both chains. And the challenge for dApp developers is the developer interfaces for interoperability between like all these different layers is super fragmented. So each one of these roll-ups, like let's say Arbitrum and Optimism, they all have a custom like bridge implementation. And so if you want your dApp to be interoperable between like Arbitrum, Optimism, and Ethereum, you got to implement like 3 different interfaces. Depending on what you're trying to do, the action, like you have to use a different pathway. So like deposits and withdrawals are one pathway. And then there's like separate pathways for bridging wrapped assets, or doing like arbitrary message passing or arbitrary contract calls on these other chains. Like all these generally you have to like use some different pathway. Maybe like the canonical bridge doesn't provide this, or it doesn't provide it at a latency that you're happy with. And so, yeah, this is like super hard as a dApp developer to actually like take advantage of all these new things. So typically what we're seeing is people are just choosing a roll-up. They're like, oh, I think Arbitrum's winning, so like I'm just going to be an Arbitrum dApp. But there's no reason that they should have to take on that risk of making that choice so early on in their product development. These are just a couple examples of like things that get unlocked once we start getting like real interoperability between heterogeneous blockchain architectures that at the infrastructure layer provide different capabilities or features. I'm going to move quickly through this. yeah, I'm going to also just move quickly through his. But okay, so Hyperlane's kind of one of Hyperlane's core ideas or insights is that in order to provide this like modular interoperability layer that developers can use across all these different infrastructure layers, we need to separate the transport layer and the application layer. And so at the application layer, we can have a consistent interface that developers can use across all of these different infrastructure layers. And depending on the kind of pair that developers are having communication move between, the transport layer might look slightly different. But all of that is going to be kind of abstracted away from the application interface that like dApp developers need to understand. And this allows dApp developers to basically no longer have to think about like maintaining multiple implementations of their protocol for different chains, for different rollups. And furthermore, like dApp developers should be able to express their preferences for security and kind of the trade-offs that they want to make in their application. So if you look at kind of like the canonical rollup bridges, like we just talked about, Arbitrum, Optimism, you know, we have a very specific fraud-proof mechanism that implies some, you know, security constraints, some latency, but it's this like omnibus model that all applications on that rollup need to opt into. And that might not make sense for your application, or it might only make sense for like one type of action that happens in your application, but otherwise, you know, you maybe don't need all that security, or you'd prefer the lower latency, like faster finality settlement pathway. So we want to allow dApp developers somehow to express their preference for these trade-offs in the interface. And as stronger verification mechanisms become available from kind of the R&D side of the ecosystem, like a bunch of people are working on, you know, ZK Lake clients, all this like signature aggregation stuff. As those become available, the dApp developer can just change a very simple configuration without changing any of their implementation to say, hey, I'm going to now apply this new security module to these set of actions that are happening between these set of chains. And that's just like a configuration layer in their smart contract instead of like a whole new implementation that they need to do to now like go and verify some new security models like messaging format. Yeah, and the final kind of like core idea that we're excited about at Hyperlane is extending this capability and this developer interface and like modular security paradigm to any chain that you guys want to be on. So we have a feature that we've been like working super hard on recently that we call like permissionless deployment, and it's this idea that someone who's like maybe spinning up their own rollup, let's say they're using like the OP stack or something, they should be able to just bring Hyperlane there independently from our organization. And so like we've basically built out the tooling for developers to deploy our protocol to their chains. And this is just way more scalable than what we've seen with like the existing bridging and messaging providers, where you have to kind of go and like lobby them and like they have to take on some amount of risk to operate on your chain, and maybe there's like not enough economic incentive for them to do that. Yeah, so this is hopefully what we're going to live demo today in a moment. Already went through that. Cool. So switching gears a little bit, the application that we're going to try and deploy today across a few different chains is called a warp route. A warp route is basically like this collection of contracts that allows you to route tokens between chains. There's a few different flavors of our warp route implementations. We have like the native flavor, which allows you to wrap native assets, like let's say ETH, and in like a single transaction, route them to some other chain. The collateral flavors for like existing tokens. And then synthetic is for how to represent those collateral tokens on chains where they're being warped to. So a warp route is like some collection of these set of primitives. And I'm not going to go super in depth here, but you should definitely check out our docs. I think the basic premise is like I don't even really want to get into the kind of how Hyperlane protocol works in this workshop, because I think it's like less interesting for the hackathon context. But there's a bunch of stuff going on here. You can imagine Bob being like a recipient application. And the idea is Bob can specify his security preferences for like what types of warped assets he wants to accept into his application. So whereas today we have like, let's say, wormhole USDC that's like bridged everywhere, that has some kind of like global security model that everyone is basically opting into if they're like using wormhole. You can actually like have different I guess like you can almost look at them as like tranches of a warped asset that is like using some specific risk tolerance or security model to verify that like those assets have indeed been kind of locked up and collateralized on some other chain, if that's the instantiation. Cool. So yeah, we've basically like built a bunch of off-the-shelf tools for you guys to play with this like warp route primitive. So the idea is like you don't even have to necessarily write your own contracts. You can deploy one of these warp routes between any chain that you want to deploy Hyperlane to, and that'll allow you to just like import liquidity. It's like a big use case that a lot of new chains are really struggling with right now, because in order to like launch a new chain, you need to establish some reason for people to like come to your chain. And that usually implies like having some economic activity. And so you need to bootstrap that somehow. And an easy way to do that is just like importing liquidity from some existing chain. You kind of like can leverage existing network effects. But if there's no token bridge operating to your new chain, you can't do that. So the combination of like being able to deploy Hyperlane to your chain and like having this nice warp route primitive allows you to like spin up a chain which can like solve this kind of cold start bootstrapping problem. Cool. So yeah, we have a bunch of different tools here for what I just described. I think Nam is gonna try and demonstrate us deploying Hyperlane to a testnet and then deploy a warp route between that testnet and maybe some public testnet. This.
Cool. All right. So like Yorke said, we'll be doing a live demo of what it's like to deploy Hyperlane to your own chain. So let's set the context here. Let's say, right, like you create your own rollup and you're just like, oh, this is all great. But like, obviously now you have to convince, right, like developers and users to come your own rollup. And right, like traditional world, like you maybe have to convince, I don't know, like Coinbase or Binance to ultimately list your token for people to actually be able to like move economic value to your rollup, right? Oh, like to your own chain. What, like I'm just using rollup as a specific instance of that. And so now with Hyperlane, you can basically deploy interoperability to your chain and connect it to any other chain that is connected to Hyperlane. And so that's what we're going to be doing. So, right, so on our docs here in our guide, we have this kind of like 5-step process of deploying Hyperlane. So the first step is just generating keys. So I guess that doesn't even count as a step. The second point is to basically deploy contracts. And so we have a Hyperlane deploy repo, which I've kind of cloned here already. And basically all you have to do is you have to add your chain, right? So basically in chains.json, oops, actually this is the wrong one here. Basically in chains, you just kind of add your like chains information. All of this really like the name, the chain ID, and then an RPC URL. So in this case, we're going to be deploying to Coinbase's new chain called Base, right? And obviously, if you're Coinbase, I guess you have your own exchange. But again, if you have, right, like deploy your own rollup here today, it's going to be very hard to convince anybody to deploy anything on your chain. So here's going to do it ourselves. So all you have to do is basically add your chain here. Like Yorke said, we have modular security. And so like in this case, what we'll be doing is we'll just deploy like a 1-out-of-1 kind of like multi-sig ISM, as we call it, to basically validate messages going from your chain to all the other chains. But actually you get to reuse the security that we already have existing like kind of default chains, as we call them. So for us, we should just be deploying between, let's say, Base and Sepolia. And so then all you have to do is, I guess I could just copy and paste that here. So basically you add your chain, you kind of configure the security, the default security from your chain, and all you have to do is like run the script, right? And I'm not going to like deploy this because it's like a bunch of transactions going to take a little bit too long. But at the end of this deployment, you basically get kind of these addresses. So in here, you get basically all the artifacts of the addresses that got deployed on both Base and Sepolia. And so that's kind of just the contracts. And then the two remaining steps are basically to run the validator, which basically validates state from your chain, in this case Base, to all the other chains, right? So that's the first step. So all you have to basically do is kind of run, we have Docker images, or you can just build it from source as we did here. And you basically say like, hey, like what's the origin chain name that I want to validate on? Where do I want to write my signatures to? So in this case, I'm just writing it to a local folder. And then basically the config file that you got from the contract deploy. And so basically once you run that validator will now observe the contract on your own chain. And basically anytime there's a new message, it will kind of like attest to that new message. The next step then is, after running a validator, is to run a relayer. And so basically a relayer is a permissionless role that basically uses the signatures from the validator to ultimately pass them on to the destination chain mailbox contract, right? And that mailbox contract basically then uses a security module that is specified to validate, hey, does this actually happen on the origin chain, and then process the message. And so basically we have relayers that run basically from like one chain to another. So in this case, you can see here, I think this is from Base to Sepolia. So we'll just run that right here. And then equivalently, we have another relayer that runs from Sepolia to Base. And so that's basically all the kind of like off-chain infrastructure that you would have to run. And now we're connected. We can kind of like easily, there's a test script I can run right now that basically just sends two messages, one from Base to Sepolia and one from Sepolia to Base. And then we should see those being delivered in 1 second. If all goes well.
Yeah, I realized I didn't like a lot of depth on like what's happening at this contract layer, but it provides color there. Like when you work contract message describing that interaction, and that message needs to be authenticated such that someone can actually know that it was your contract that dispatched this action rather than some malicious attacker. And so we have a few different security models that you can select off the shelf to like perform that authentication. One is this like multi-sig validator setup, where basically there's validators on the source chain that are signing commitments to the messages that have been dispatched from that chain, such that those signatures can be used on the destination chain as an attestation that, hey, this message was dispatched on this source chain. Eventually, the idea is to have kind of like permissionless economic security model where anyone can be a validator if they're putting up enough stake and provide security to this type of authentication system. But yeah, what's happening here is the message is being committed to on, let's say, Sepolia, and then the validator that Nam's running on his machine is signing a commitment, and then the relayer that he's running on his machine is taking that signature and passing it to the destination chain contracts, which is like one of these warp route contracts that's basically verifying, like we saw in the multisig ISM config that he had up earlier. It's verifying that we've reached a threshold of the specified validators that have like attested to the fact that this message was like committed to on the source chain. But yeah, definitely for more details, check out our docs on kind of all the different types of security configurations.
Cool. So basically now that we've kind of verified that we can send messages back and forth, right? Like we've kind of connected this new chain that didn't have Hyperlane before to all the other chains that have Hyperlane. And so now that you have kind of this base messaging layer on kind of set up, you can build applications on top of that, right? And like Yorke said, I think a very common application is effectively a token bridge, right? So let's say, again, if you're a new chain, like one of the first things you probably want is like you want a stable coin, right? And so why don't we just kind of like create a warp route of, let's say, like something like USDC that exists on Sepolia to like your new chain, which in this case is Base. And so we once again have a guide for that, right? So under warp routes, here you, again, just go off Hyperlane deploy and you just run a different script. The script basically is configured with this warp route config. So let's say in this case, swarp route, is it? I guess we call it warp tokens now, right? So that's basically we say like on the base chain, which I guess is like the collateral chain, we basically say like, hey, we want to collateralize this token, which in this case I think is just a link token because there's a good faucet on it on Sepolia. And basically we want to say like, hey, we want to create synthetic versions of that token on, let's say, another chain, in this case, our base token. I see how that naming can be a little confusing in this particular instance, right? But basically we allow now to create a warp route between Sepolia and Base. And so then all we have to do is, what's it called? Deploy warp routes, right? With basically our private key to kind of deploy the contracts. And I think that's what happened above here. So again, I'm not going to run through it because the transactions take, I think, a couple of minutes. And the cool thing is that like once you've kind of deployed this warp route, right, which is basically just a set of smart contracts on both chains, we actually have a like out of the box UI that you can use to kind of let your users now leverage this warp route to kind of have these like synthetic tokens. And so all you have to do is basically take the output of your warp route deployment and basically add that to this like template repo that we have that you can clone. Again, all you have to do is add your chain information in here, and you add the token information from the warp route deployment. And I can do like, in this case, I can just like kind of run it locally right here, but it also like super easily deploys to Vercel or any other like Next.js hoster. And so basically then here on localhost, it will basically fetch kind of the warp route information, and then after a little bit, will show you, right, like the kind of the chain options for your warp route. You can see the token that you can kind of warp. You can say, hey, I want to send this much. The recipient, you can just say it to yourself, and then basically send it to Base. And again, this is all out of the box, right? I didn't have to change any code. It will prompt me to approve my link token to the warp route contract on Sepolia. And once the approval happens, and if the Wi-Fi is good enough, Ultimately, it will.
If you guys saw the Layer Zero, like Gorley ETH market drama a couple weeks ago, this is like a tool where you can create those type of markets between any chain's assets super easily. So if you guys want to, like in this hackathon, go mess with someone else's testnet, you could maybe do that.
Cool. All right. Then we saw basically the second transaction, right, is to actually ultimately send the tokens over to Base. And so that, I guess, just confirmed on Sepolia. So like Yorke said previously, again, like validators will basically attest to that transfer on Sepolia, create signatures, and then the relayer that I'm running right here will basically observe that message and will ultimately process it on Base. And so I think what we can do actually is just to take the yes, so we can basically take this is the token address on Base, right? So we can just go to Base, I think, what is it, Base Etherscan? I forget what it is. What was it? I just had it. I think they call it Base Scan. And then you can kind of put in the token address, right? So that's basically like, you can already see here, it's like shows up as a Chainlink, even though I'm pretty sure Chainlink doesn't have it deployed the token on Base. And then under, I think that tokens transfers, you can see here, like 25 seconds ago, we just minted ourselves 0.001 Chainlink token on Base. And then I think in the UI, yeah, like you can kind of see the same thing. And then like if we wanted to, right, like we can send it back from Base back to Sepolia again. And yeah, you can imagine what the kind of outcome of that is. I'm told we're out of time. So if you have any more questions, feel free to jump by our booth today. We have 3 bounties. One is for the best use of permissionless interoperability. So basically, right, like you could deploy to many of the networks that are represented here today as well. And kind of like, would love to see kind of some cool use cases between, let's say, like, a new chain and like an existing chain. The second bounty is for best use of the warp routes, right? So like bring your token to some new chain and like kind of do something useful for that. And the third is, like we said, we have this kind of modular security approach where developers can choose different trade-offs. And we would love for developers to kind of build some kind of like alternative models, like an optimistic one, or like maybe one based on succinct, like kind of like ZK light clients. But like, because we believe that the story hasn't been kind of finished telling yet about what security models are out there for cross-chain interoperability, we would love for hackers to kind of like play around with that. I think that's it. Thank you.